Okay, so we are going to read chapter 4 of the History of Mathematics, and I will attempt to do my best with all the pronunciations of the names as we go through. Should be fun. Okay, chapter 4. Zoom in a little bit. Chapter 4. The period from 300 BC to 500 AD. The School of Alexandria. Chronological and geographical considerations. The reason why the limitations of 300 BC and 500 AD are arbitrarily chosen for this chapter is that these dates mark approximately the period of influence of the greatest mathematical school of ancient times, the School of Alexandria. Moreover, the first of these dates is approximately that of Euclid, the world's greatest textbook writer, and the second is that of Boethius, whom Gibbon characterizes as the last of the Romans whom Cato or Tully could have acknowledged for their countrymen. Within this period, Greek civilization passed away. Rome rose and fell, and the ancient mathematics of the West descended from its most exalted to its most debased estate. We have, therefore, the most significant period of the ancient mathematical history, at least in the matter of actual production, and we have the Mediterranean world, probably the most interesting of all ancient civilizations. The School of Alexandria. The greatest mathematical center of ancient times was neither Crotona nor Athens, but Alexandria. Here it was, in the site of the ancient town of Rhakotis, in the Nile Delta, that Alexander the Great founded a city worthy to bear his name. Upon the death of the great Macedonian conqueror, 323 BC, the vast domain which he had brought under his control was broken up. After the death of Antigonus, his ablest general, the empire fell into three parts. Alexander's friend and counselor, and possibly his blood relative, Ptolemy Soter, Ptolemy the Preserver, came into possession of Egypt. Antigonus the Younger laid claim to Macedonia, while Seleucus took for his part the provinces of Asia. Under Ptolemy's benevolent reign, from 323 to 283 BC, Alexandria became the center not only of the world's commerce, but also of its literary and scientific activity. Here, we established the greatest of the world's ancient libraries and its first international university. Cardinal Newman, in speaking of these two features, says with poetic feeling that, as the first was the embalming of dead genius, so the second was the endowment of living. Here were trained more great mathematicians than in any other scientific center of the ancient world. With Alexandria are connected the names of Euclid, Archimedes, Apollonius, Eratosthenes, Ptolemy, the astronomer, Hieron, Menelaus, Papias, Theon, Hypatia, Diphotenus, and at least indirectly, Nicomacheus. Today, however, not the slightest trace remains of the famous library and museum. And even their exact locations are merely conjectural. Section 2, Euclid. Euclid, of all the great names connected with Alexandria, that of Euclid is the best known. He was the most successful textbook writer that the world has ever known. Over 1,000 editions of his geometry having appeared in print since 1482, and manuscripts of this work having dominated the teaching of the subject for 1,800 years preceding that time. Wow. He is the only man to whom there ever came, or ever can come again, the glory of having successfully incorporated in his own writings all the essential parts of the accumulated mathematical knowledge of his time. That's an impressive statement. Continuing on page 105. Of the life of Euclid, nothing definite is known. A recent writer expresses the belief that the evidence indicates that he was born as early as 365 BC and that he wrote the Elements when he was about 40 years old. But we have no precise information as to his birthplace, the dates of his birth and the death, or even his nationality. It was formerly asserted that he was born at Megara, a Greek city, but it is now known that Euclid of Megara was a philosopher who lived a century before Euclid of Alexandria. The Euclid in whom we are interested may have been a Greek, or may have been an Egyptian who came to the Greek colonial city of Alexandria to learn and to teach. There is some reason for believing that he studied in Athens, but in the way of exact information, we have nothing concerning him. Under any circumstances, the period of his real influence upon mathematics begins about 300 BC. The books of Euclid, as was the custom in the days when all the treatises were written on long strips of parchment or papyrus, the separate parts of his work were rolled up and called volumes, from a Latin root meaning to roll. So we look over here, parchment roll in this diagram. Upon such a roll, a book of Euclid was written. Because of the difficulty of handling large rolls, they were cut into smaller rolls known as biblia, Bibles, a word meaning books. Hence, we have the books of Homer, the books of geometry, the books of the Bible, and so on. Euclid's greatest work is known as the Elements, and in the books relating to geometry there was arranged that mass of material treating of circles, rectilinear figures, and ratios which had accumulated during the 2 centuries following the death of Pythagoras. No doubt there were also many propositions that were original with Euclid, but the feature which made his treatise famous, and which see if I can scroll up and over. And which accounts for the fact that it is the oldest scientific textbook still in actual use, is found in its simple but logical sequence of theorems and problems. It has been said of Shakespeare that he took the stillborn children of lesser men's brains and breathed on them the breath of life. And so it was with Euclid. Contents of the Elements. The various books of the Elements treated of the following topics, respectively. 1 was the congruence, parallels, the Pythagorean theorem. Book 2, identities, which we would now treat algebraically, like a plus b squared equals a squared plus 2ab plus b squared, but which were then treated geometrically. Areas, the golden section. 3, circles. Book 4, inscribed and circumscribed polygons. Book 5, proportion, treated geometrically and part of geometric way of solving fractional algebraic equations. 6, similarity of polygons. 7 through 9, arithmetic, the ancient theory of numbers treated geometrically. 10, incommensurable magnitudes. There it is. Books 11 through 13, solid geometry. We have in this text the earliest extant evidence of the systematic arrangement of definitions, axioms, postulates, and propositions. Euclid differs from most of our modern writers on geometry in his greater seriousness of purpose, and his desire to be more rigorous and in the following details of treatment. He has no intuitive geometry as an introduction to the logical. He uses no algebra as such. He demonstrates the correctness of his construction before using them, whereas we commonly assume the possibility of constructing figures and postpone our proofs relating to constructions until we have a fair body of theorems. He does not fear to treat incommensurable magnitudes in a perfectly logical manner, and he has no exercises of any kind. And that's how we will end chapter 4. And we'll call this History Math chapter 4-1.